Hi guys, it's DeGrow, and we're going to be looking at histograms today in this video. So if you're following along on our stats packet, we're on page 12 at the beginning of this, and you should take a couple minutes and go through the warm-ups and see what you can think about them. So just take a second and pause the video and read the first couple of questions and see if you can make your conclusions about these histograms. Give me a second, pause it. Think about them, write down your conclusions, and then restart it in a couple seconds, and I'll keep talking here in a second. Alright, so the conclusion you should have is that the GPAs of students who do not play a sport is higher than those that do play a sport. Now the graphs are misleading. What you got to really pay attention to is the numbers at the bottom of the screen. So for the ones that do not play a sport, the low end of that is a 3, whereas the higher end is a 4. And on those who do play a sport, the low end is a 2.4 and the high end is it's kind of hard to tell. Maybe a 3.1. I think each of these is going by 0.1. And it's still a little bit hard to tell exactly what this is implying because this 2.4 is on the low end. So is it 2.4 to 2.5? But either way, you really have this whole idea that the one on the left is actually completely above the one on the right. Now the graph on the right is heavier towards the 3 side, but still the low end of the GPA of students who do not play a sport is higher than the GPA of students that do play a sport. I feel like this doesn't fit with at least with my background, because anytime I was in the sport I had less time to work, which would make it seem like your score would go down, but I never slacked. However, these are supposed to be college students, and playing a college sport might be completely different than playing a high school sport, whereas college you only have so much time in a day and a ton more work. So even though it's not my personal experience with this, it might still be a true statement. Okay, so these are histograms, and the big difference between histograms and bar charts is these are categorical data. All these numbers at the bottom here, these are just numbers. They're not categories. Now you could think of this as being like low, medium, and high achieving students, and you could think of them as categories, but there's a big difference between a 3.3 and a 3.2. Like, the numbers make sense, and a good way of keeping track of that is if I take an average, does it make sense? Can you have an average GPA? Yes. However, can you have let's say if they were eye colors and you have green, blue, and hazel, can you take an average of green, blue, and hazel? And the answer is generally no, you can't do that. So when we take a histogram versus a bar chart, that's the main difference. Bar charts are for categorical, and histograms are for either numerical or quantitative. Another thing that's different between a bar chart and a histogram is our histograms over here, you see how there's not really a gap. Now, there can be gaps, but these represent that there's no student that had a GPA between a 2.6 and a 2.7. That's what that signifies. When you do a bar chart, generally you do have gaps between them, but they're just gaps between the different categories. Now, most of the times there usually is a space between them, but let's say that you had 3 categories and somebody just chose to stack them next to each other. That'd be okay, and you probably understand it just fine, but a histogram, if there's a space in a histogram, it means that there's no observations in that category. Alright, so let's talk about how do you create a histogram. Alright, so before we talk about how do you create one, why do you do this? You can see the shape, you can see the center, and you can see the spread. When we're describing a distribution, you need to see all 3 of these things when you're talking about it. When you use one, the other thing you can say is you use a histogram when it's quantitative. That's when, but you can see the shape, center, spread. You can see if something is symmetrically distributed. You can see if it's skewed to the right or skewed to the left. And you can see if it's all clustered around the middle versus if it's spread way out. Okay? We'll talk a lot about shape, center, spread as we go, but a histogram lets you see all of these things. Some things it doesn't tell you. We haven't talked about outliers yet, but a histogram won't really tell you an outlier. Like, you could have a histogram that looks something like this. Everything's kind of around this area, and then there's one little guy over here. This guy may be an outlier, may not be an outlier, but at the same point, like, you can still see it. It's not defined as an outlier as far as a histogram is concerned. There's other ways of finding out when things are outliers. Oh, sorry. Scroll this guy down. Okay, so as far as shape, center, and spread. So the shape, you're looking for two things. You're looking for, is it symmetric, or if it's skewed. And you're always looking for, there's multiple shapes you can have. You have symmetric, that would be the same thing on both sides. And if it's skewed now, talk about skewed to the right would look something like this, and skewed, and you always think of this as being skiing, this guy's skewing down to the right. I know a lot of people think that all the heavy stuff is here on the left, and so they think that the whole thing slid to the left. And I can see that, but what happens is you end up with an average that gets pulled from the median. So the average is going to be way out to the right, and the median will be on the left of the average. And again, we'll talk a lot about this. This will be skewed to the left. Now that's not the only options. It can be symmetric, it can be skewed, it could also be uniform. This would be a uniform distribution. Now when you're reporting on the shape, you need to talk about whether it's symmetric or whether it's skewed. But you always want to mention possible outliers. And if you're told to describe a distribution, you have to talk about the shape, you have to talk about the center, you have to talk about the spread. Alright, let's move this down a little bit, and then we can see the other ones. Okay, so the center could be mean or median. And when you're making a histogram, you can generally find either one of them. Median might be a little bit easier for in a histogram, and the thing is, if it's symmetric, you want to use the mean, and if it's skewed or there's outliers, you want to use the median. And the reason for that is the median, let's say you're having a set of numbers, 1, 2, 3. The median's 2. Let's say that I replace the 3 with a 10. What's the median? Still 2. But going between 1, 2, and 3, the mean, average, if you add them all up, 4, 6 divided by 3, that's 2 still. But the mean changes all of a sudden when I change the 3 to a 10. So if you have outliers, or if you have a skewness, you really want to talk about the median because it's resistant to those things. And if not, if it's symmetric, you want to talk about the average. The spread, there's a lot of measures of spread. There's the range, which is probably the easiest for us right now, which is the highest minus the lowest. It's really easy. If you're going from numbers like 1 to 10, so the range would be 9. Now, other measures of range of spread that we can talk about are the standard deviations, which we don't know how to do yet. The interquartile range would be another one, but for right now, just the range, the high minus the low would be fine. And sometimes it's okay to say, I'm talking from 1 to 10. And especially when you're talking to people, I actually like that better than 9 because it tells you where as well. Alright, so you want to talk about major peaks, like, is there a peak? Now, it's not so much that. A lot of times if you saw this, I would say it's symmetric, and it's got a spread of whatever the numbers are. But let's say that there are 2. It might be bimodal. Or it could be polymodal. You have many modes. And then always mention your outliers. And again, there's going to be a rule for outliers later on, but if something looks like an outlier, you got this going on, and you got a little bump somewhere later on, you want to mention that. The whole idea of describing a distribution is you're supposed to talk about everything that's important. And if you saw this, if you had numbers like 1 through 10, and all of a sudden there was 30, where the 30 becomes an actual outlier, now you usually should mention it, because that would be the most interesting thing on your graph. Some of that stuff's a little bit repetitive. Okay, again, these are the different shapes you might have. Not all the shapes, but this would be skewed right. This would be symmetric. And actually, why don't you take a second and see if you can figure out what you would call all these things. and then unpause it and see what I got. So this would be skew left. And again, think of them as skiing down these hills. I would say this is bimodal. That'd be the most important part about this, is uniform. Now, a uniform distribution, I mean, it's not perfectly uniform, like one of these is higher than others, right? But think about rolling dice. I would expect all of them to be numbers 1 through 6 even. But if I really recorded it, some numbers are going to roll higher more often than other numbers. If you roll them a billion times, I really expect all of them to be pretty close to each other, but I don't expect them, like if I roll 6 times, I don't expect numbers 1 through 6. Like, I'll get other numbers. Now, something we want to start trying to memorize is the order in which these things are. So if it's skewed left, it does go mean, median, mode from the left-hand side. If it's symmetric, the mean, median, mode are going to be right in the middle way. If it's skewed to the right, they go from the right as a mean, median, mode. So the idea is these numbers that are way out here are going to pull the average out to the right. They're skewing the average to the right of the median. And you don't really talk about mode in this class at all. You can, but you don't need to.